Hello everyone, welcome back to our channel. Let's see the next named reaction, that is Beirut reaction. This reaction is also called as Davies-Beirut reaction. Let us discuss the complete concept of this particular reaction. The first component is what? Statement. If you see the statement, base catalyzed conversion of orthonitrobenzyl amines to 3-alkoxy-2H indazoles. It means that what? This reaction is useful for the synthesis of different kinds of biologically active indazole derivatives. So what are these indazole derivatives? We all know that the structure of indole. How can we write the structure? The indole is represented like this or not? It is having one benzene ring fused with what? A 5-membered pyrrole ring. This is indole. Suppose if you place one more hydrogen at the second position, then those type of compounds are commonly called as indazoles. See this one. 1H indazole, 2H indazole. With respect to this particular nitrogen, the second nitrogen occupies the second position. It means if both the nitrogen atoms are adjacent to each other, then those type of compounds are commonly called as indazole derivative. If the hydrogen is present at the first nitrogen, that is commonly called as what? 1H indazole. If the hydrogen is present at the second nitrogen, then that is commonly called as 2H indazole. This particular reaction is useful for the synthesis of different 2H indazole derivatives. Remember that. In order to synthesize the 2H indazole derivatives, we need to take the reactants. Those are what? Orthonitrobenzyl amines. Nitrobenzyl amines must be the reactants. See this one? This is the benzene ring. If you see the position, this is ortho position or not with respect to this particular benzyl group. So this is orthonitrobenzyl amine. This is which kind of catalyzed reaction? Base catalyzed reaction. So we have taken the base and also one alcohol. It is going to be converted into 3-alkoxy substituted. Why? Because here we are having alkoxy group. That's why this OR dash group is going to attach at the third position. 3-alkoxy substituted indole derivatives. Let's see the mechanism. We know that in this particular reaction, the reactants are what? Orthonitrobenzyl amines. The general representation is like this. Initially what we are doing, we are using a base or not? Generally what is the use of the base? The base is used to remove the protons from the acidic position. Initially what happens? From the benzylic position, we are going to remove the proton. Thereby what happens? We are going to create negative charge at this particular carbon. See this one? We have created carbene ion. After the formation of the carbene ion, what is happening? This step is very important. Carefully listen. Here we have removed H plus ion or not? The removed H plus ion move towards this O minus. So the O minus and H plus produces what? OH or not? So here what is happening? This bond is subjected to heterolytic cleavage. Thereby what is happening? We are giving negative charge to the nitrogen. Already positive charge is present. We are giving the negative. So positive and negative both will be neutralized or not? That's why it is going to be converted into N double bond O. Now what happens? The O minus is taking what? H plus, thereby O minus converted into OH or not? After the formation of OH here, what is happening? These bonding electrons move towards nitrogen. That means we are creating a positive charge on the oxygen. Thereby what happens? The OH is going to attach at this C minus. Thereby we are getting what? COH bond. Okay. In the next step, what is happening? From the nitrogen, the hydrogen is going to be removed in the form of H plus. Thereby we have created negative charge on the nitrogen But at the same time, what happens? Oxygen having the lone pair of electrons or not. So these lone pair of electrons are going to take this H plus ion. Thereby the OH is converted into OH2 plus. So see this N minus and OH2 plus. The minus charge is involving in the formation of a pi bond. Thereby what happens? We are going to get the carbon nitrogen pi bond. Here valency of carbon is increasing. So in order to satisfy its valency, what is happening? The OH2 will be removed in the form of water. See this? We will come up with this type of C double bond N. See the product. It is a cyclic product or not? The cyclic product containing 6-membered ring fused with 5-membered ring. Already we have the 6-membered ring. Now we need what? A 5-membered ring. So in order to create the 5-membered ring, what we are doing? See this one. Here we have alcohol or not? Alcohol is dissolved in the what? Base. It means that what? It is going to create RO minus ions or not? Alcohol and this one. The H and OH removed in the form of H2O and RO dash minus and K plus. These OR dash minus ions will be attacking at this particular carbon. See this? OR dash minus is going to attack at this particular carbon. Thereby what happens? The pi bonding electrons move towards the nitrogen. So nitrogen will take the negative charge or not? This negative charge approaches to the upper nitrogen. Thereby these pi bonding electrons move towards the oxygen. See this one? 1, 2, 3, 4 and 5. The 5-membered ring connectivity takes place. This N pi bond is converted into what? N single bond. So in the solution we are having water molecules. That's why what happens? The H plus ions will be taken from the H2O. Thereby the O minus is converted into OH. Okay, if you see the product, in the product what is happening? The 5-membered ring containing 2 adjacent pi bonds. We need to create those adjacent pi bonds. So in order to create those adjacent pi bonds, what we are doing? At this particular carbon we are having a proton. That proton is going to involving in the conjugation. Thereby what happens? Elimination of H and OH removed in the form of H2O. Thereby we will come up with what? The corresponding indazole compound. So 1, 2, 3. Third position we are having alkoxy group. Alkoxy substituted 2H indazole. So in this way we can simply convert the orthonitrobenzyl amines to the corresponding 2H indazole derivative. If you see the applications, in the applications we are having two main important compounds. If you see these compounds, this is the main indazole moiety. The indazole moiety connected to what? Another heterocyclic carbon. This is the indazole moiety. The indazole moiety connected to what? Other heterocyclic carbon. It means that what? The indazole compounds can be acted as the intermediates for the preparation of different kinds of the heterocyclic compounds which are having biological activities. So simply we can say that indazoles are itself having the biological properties and also involved in the preparation of different kinds of the heterocyclic moieties. So this is all about what? Your Beirut reaction. This is also commonly called as what? Davies-Beirut reaction.